Hello, my name is Rolf Green, and I'm doing the video presentation of the Alpaca Research Investment Chart Singleton. In the first place, I think I would like to demonstrate how the chart works using the command prompt. You can see here there's an illustration of the chart on the top left. I'm using a video presentation on the bottom right and on the top right, and then we have the command prompt right here on the bottom left. So if we focus on that, I'll show you how it works. In the process of creating the Singleton application, I had a lot of practice. As you can see, I've made numerous applications. But the one I was able to focus on and work successfully was called the what was it called? It was called the mock application lightweight, PY. I can illustrate to you how that works just using the mock data, and I'll be able to present how I was able to change that and use that for the Singleton application. We'll go down below to the command prompt and apply the mock illustration using the browser. In this case, it uses the browser by referring to the local URL. As you can see here, I'm highlighting it down below, http://127.0.0.1:5000. If I go to the browser now, you'll be able to see clearly, hopefully, if it's still working here, the appearance of the chart. Okay, let's try again. Didn't quite capture that. Okay, now we are in the local browser, and you can see the chart appears using the mock data. This gave me a solution to creating the Singleton application because of its simplicity. We have a more advanced application that uses real data and the trading view that I showed in another video, but this turned out to be a real benefit to have this application showing mock data. And we'll go on to show how the Singleton application used this mock data impression to create a really great chart using Singleton. So first of all, let's Control-C and clear up the browser. We'll start anew and click directory. We're going to be looking for Singleton Real App Lightweight PY. This is our new file that we created based on the Singleton mock. By the way, I did create a Singleton mock here using Singleton with the mock application, but I wanted to illustrate to you that the Singleton was based on a mock application. And in this case, we're using the Singleton to make a real application of the Python chart. Okay, let's put it in the command prompt. We'll let it run. It will give us a browser address. And we go to 5000 port. This is going to be an important point as well, because this port selection is actually vital. So I copy that, I go to the Google browser, and let's see if we can find real data using the Singleton application. Okay, so that worked. We have a browser with a real chart using real data, and it shows moving averages, 20-day and 5-day, and prices on the right, and time frame over 30 days from the left to the right on the bottom, the x-axis. Okay, now I can also change this, by the way. I'm using Apple right here as a template. But let's say I wanted to look up Microsoft. It will update the chart as well. Now we're looking at Microsoft data. Let's see, shouldn't it update it? Okay, so we have an error here. It's still stuck on, maybe I'm using a wrong symbol. Try BST. Okay, so that updated. I happened to use a wrong symbol, and the error messaging handled it previously. But now we're looking at Vistra, and the Vistra chart is showing the data for the 20-day moving average and the 5-day moving average, and prices on the right, and time the month from the left to the right on the bottom. So let's close this, and we'll get back to our explanation. Now you see how the chart works. Of course, you can make mistakes and put in the wrong symbol. We'll close out the command prompt and get back to clearing the browser, clearing the command prompt if we need to use it later. My aim here is to provide a presentation for the successful completion of the Alpaca research investment chart, Singleton. The 5 to 10 minute presentation has a video narration that shows accomplished tasks 1 and 2 that address the common problems and the functions used to resolve them during the troubleshooting process, and it makes recommendations, for example, production later. I also note the previous attempt that failed numerous times due to persistent port 5000 errors until I resorted to using my successful mock demonstration to implement the Singleton app. From there, I went on to show a Singleton Alpaca research investment chart that uses real data in its browser appearance. And that was a big step to move from mock data to real data, as I showed you with the Vistra. I'm thrilled that the Singleton app finally worked as intended. This outline for a 5 to 10 minute video narration captures what the app accomplishes, including the tasks, common problems, troubleshooting steps, and recommendations. It carefully notes the previous attempts plagued by persistent port 5000 errors, the pivot to the mock data demonstration, and the successful transition to real data. This outline provides the narration of the journey of building and troubleshooting the app in a clear and engaging way. Now, the video narration outline is the building and troubleshooting of the Alpaca lightweight chart app. And here in the introduction, I point out the use of the Singleton Get Instance application. It was originally reviewed in my instruction on how to use Get Instance, and I wanted sincerely to see if I could make a useful, efficient application. And hi everyone out there. Today I'm excited to share my journey of building a lightweight stock chart app using the Alpaca API to display real data, all the while implementing the Singleton design pattern. In addition, the original mock data used the Singleton, but it was very basic until I added the Get Instance function to the program, and we'll be able to show you that when I open up the Python program itself. I'll cover the key tasks, the challenges I faced, like persistent port errors, how I resolved them, and what I learned along the way. So let's dive in. Building the initial app with mock data. That was my initial objective, and I used it to test the Singleton Get instance app, providing a basis not just to improve the overall performance of the chart system, but to provide security and control of the centralized system for future production. The original task only produced a simple Flask app that displays the stock chart using mock data running on http://127.0.1:5000, as I show you on the top left chart that appears in the local browser. Nevertheless, the simplicity of the model provided advantages to the later Singleton application because it actually worked after numerous attempts that had otherwise failed. Now, the steps I used started with setting up a Flask app with the Singleton pattern in Singleton mock app lightweight.py, ensuring only one instance of the app exists. Of course, the name of the file is Singleton mock app. That was initially what we used, and then I changed that to Singleton real app lightweight.py since we were using real data. I created the template mock index lightweight HTML to render a chart using the lightweight charts library for the mock data. And that app generated mock data for a stock symbol like AAPL, showing candlesticks, volume, and moving averages, 5-day and 20-day moving averages, as I illustrated in the beginning. I also added a brain.ico favicon and loaded in the loading indicators to enhance the user experiences. The success occurred in that the initial version worked perfectly, displaying a chart with mock data and basic statistics like current price and average volume. This is the data that appeared in the mock. Originally, it was similar to this, except that it would say up above mock data. And in the case of the historical data that we used, that allowed us to provide real prices and data. The transition to the real data with the Alpaca API and the use of the Singleton application. My objective in the second task was to upgrade the app to fetch real stock data from the Alpaca API. I did so by modifying the Singleton pattern already applied in the mock data application and specifying the get instance function in the Python file while continuing to run it on the same port 5000 successfully. Now what I'll do here is I'll go to File Explorer and I'll show you an example of how that works with the code. Let's go to the application and its file. Actually, I need to go down below. This will take just a moment to look up the working file that runs the program. And then we'll be able to open it. It's in the Alpaca directory, nested carefully in a separate location with all the new files. And we go to the latest update, which is Singleton mock app originally and Singleton real app. Now that's the one we're going to look at. Let's open it with, we can open it with Fonny's fine, so we'll do that. And what I want to do is show you where the get instance application is located. With the mock application, there isn't a Singleton is applied, but it's not specified in that case with the get instance function. So what we did was we put it in the file. And you can see it here. Get instance. Should be here. Class instance, so on. Yes, right here. Define get instance. Here's the class right above. It's the class method for the Flask Singleton. And the API keys are used automatically in a separately configured file that becomes secured by the Singleton application. And as you can see, there's a method get instance, define get instance class, and it is directly working the chart by selecting the APIs, the secret key, the key and the secret key from the .nv file. And I'll go on to explain that further in the presentation. Well, I'll close these File Explorer. Okay. Now I installed with the Singleton Real app, I installed necessary packages like Flask, Python -.nv for environment variables, and Alpaca -py for API access. I configured the app to load Alpaca paper trading API keys from a .nv file and fetch historical data for the past 30 days. And you can see it in the app here on the top left. It's the real data for 30 days with the 5-day and 20-day moving averages. See, this 20-day, 5-day, and this one has the APL price. And that is just a picture, so I can't necessarily run that. Okay, and of course I didn't want to drop that out of view, but that's okay. Let's get it back. There we are, Singleton Real Data. Let me see if I can do that a little bit more efficiently. And close the Explorer. Now, that's a lot to have covered, but the important point is that we completed task 2 and we reverted to a mark system to complete task 1, and that kind of like was the breakthrough. Now, my objective in completing task 2 was to upgrade the app to fetch real stock data from the Alpaca API, and I did so by modifying the Singleton pattern already applied and specifying the getInstance function in the Python file while continuing to run it on the same port 5000 successfully. Now the steps involved my renaming the files, as I mentioned, to a real application using historical data. And I installed the necessary packages as mentioned. I configured the app to load the API centrally, and then it's successfully displayed. My previous attempt showed a lot of port 5000 errors, and initially I thought it wouldn't work at all, but I decided to use my wits and applied the application that was already working very well, even though it seemed simple at first. The challenge: before this success, I faced a setback when trying to deploy the app in production mode using Waitress on port 8000. I wanted to get it to actually efficiently use real data that was dynamic. I encountered persistent port 5000 errors because the browser was still trying to fetch data from http://127.0.01:5000, where the development server was no longer running. I pivoted back to the real data using the Mark template so that I could reliably reach port 5000, helping me to complete the core functionality, confirm that the core functionality was intact. Now, the reason that happened was because some of these systems are designed for higher level uh, use on Linux and I guess big machine, and I am working on a Windows desktop, so I had to kind of focus on the manner in which it works on Windows, and it does work on Windows as we can see right now. I realized the port mismatch was an issue, so I returned to the development server on port 5000, ensuring the browser accessed the correct port and successfully transitioned back to real data. And the problem with the port mismatch. One common issue was the port mismatch between the browser expecting port 5000 and the server running on port 8000 with Waitress. Function used, I resolved this by ensuring the browser accessed the 5000 port number 5000. And I closed all the old tabs to avoid confusion. I ran into network issues. I also faced those, and the pip install failing because of that, and I had to check the network, make sure it was working, until the Flask logs no longer showed errors and showed a stable internet connection. Also, with the problem, third problem with the API authentication, you have to use an authorized API key. Otherwise, it will show a 401 unauthorized app, and the function won't work. I verified the keys in the NV file and ensured their use of paper trading keys and not live keys. Nevertheless, it gives historical data that's real price information. And with the Windows, I solved the Windows compatibility issue dealing with production servers by deploying Windows. Goonicorn failed, so I uninstalled it, and so did Waitress, because that's applicable in the future for a larger organization using Linux. I reverted back to the Flask development server, which works reliably on Windows, avoiding any production deployment issues for now. And my recommendations here are to stick to the development server for Windows users so that it can access the 5000 port and present the chart. In future production, you might want to deploy using AWS or DigitalOcean with Goonicorn and Nginx, which are more compatible with Flask applications, although they use Linux systems and larger systems altogether. I enhanced the app. I improved the application, added symbol validation to ensure proper stock symbols, and caching to reduce API calls or real-time data streaming using Alpaca's IB socket API. Backup and version control. I saved a backup of all my working files for GitHub use and version control. So in final recap here, I successfully built a Singleton Flask app that displays real stock data from the Alpaca API. I overcame port and compatibility challenges and got back to a working chart with real data. In closing, thanks for joining me on this journey. I hope this video helps you to build and troubleshoot your own Flask applications using Singleton with the gate instance function. Let me know in the comments if you'd like to see more features added to this application in the future, and I'll see you next time.